Good morning, everyone. It is now Tuesday, September 23rd for you all, and you should be in Algebra 2. I hope you're all doing well and that you are happy to see my face again. I hope yesterday's homework went well. You guys were doing your due diligence to find the slope from a graph line and finding the slope through 2 points. So I'm going to do a review of one of the problems. I'm going to do number 19, and then we'll head over to the actual lesson today. It's not too challenging, but I could see you guys getting a little lost, but you guys can totally do this, okay? Miss Andres, thank you for being here today, by the way. Thank you. Number 19. So we have our ordered pairs, negative 12, comma 6, and we've got negative 12, comma 19. We're asked to find the slope of the given points. Okay, so to find the slope again, the equation is y2 minus y1 over x2 minus x1. Best tactic again is to label your ordered pairs so that you do not confuse them, right? So I'm making this one my x1. So if that one is my x1, then this one is my y1. And then this one is my x2, and this one is my y2. Awesome. From here, let's just plug in. So y2 is 19. y1 is 6. So 19 minus 6 over, we got negative 12 for x2 minus negative 12. What did two negatives do to one another? They become a positive. Good job. Negative 12 plus 12. Okay, 19 minus 6 is 13. What is negative 12 plus 12? 0. Can I divide by 0? Can 0 ever be in my denominator? No. What solution do I get? Undefined. Okay. I hope that the homework overall went well for you all. If you still have questions, if you're still struggling, please make sure that you either write me a little note somewhere in your notes, like Miss Bruno, ask Miss Bruno about this problem on this page. And then when I get back on Thursday, I can answer all the questions you have. But I pray that you guys are all doing well. This should not be too bad. Now, let us continue and ideally finish 2.2, graphs of linear equations. So as we already discussed, we have been working with slope, which is our rise over run. Slope equals our rise over run. And as we said earlier, it's y2 minus y1 over x2 minus x1. Now, we do have to recognize that, and I wrote this yesterday, or the day before yesterday, that slope is also equal to the change of y over the change of x. This means that slope equals a rate of change. When I want to know how is this changing, or at what speed is this changing, or in which way is this changing, I look for slope, which is my rate of change. Okay. Now, to solve for acceleration, if you were ever asked for acceleration, it is always the rate at which an object's velocity changes. So basically, in simpler terms, is how fast my velocity slash speed changes. Okay. You may be thinking, why do I need to know this? Well, because, as you can probably guess, we have a nice word problem coming up. So I hope you have this. If you don't just yet, Miss Andres, please pause for a moment. Don't give them too much time. This shouldn't take them long to take down. Okay. Looking in your book, go to page 65 if you haven't realized we're there yet. So I'll put it here. Page 65. What page? Page 65. I don't know if you guys are responding. I hope you guys are, but yes. There's an example there. I wrote it down. You guys do not have to write down the word problem example. So I wrote it down for us. As I do it, I just want you to have in front of you. Do your best not to look at the answer, please. It does you a disservice to not actually solve out the answer, the question. It says, a two-stage model rocket was launched and its velocity graphed. So here's a graph of the rocket launching and its velocity. Determine the rocket's acceleration during the first and second stages of its flight. So I want to know its acceleration, and we said that this actually equals the rate at which an object's velocity changes. And grabbing from the fact that we are in a slope section, I would be inclined to think, well, maybe I'm solving for slope somehow. Maybe I have to do rise over run. Well, you would be correct. Here's my velocity on my graph. Here's the time. I want to know what is the slope between change in velocity, because remember, it's always y2 minus y1, so this is my y line, correct, over change in time. Okay, to do these problems, just as we did with the graphs earlier, that I look for 2 points that I can pinpoint on the line, I'm going to do that here as well. So let us zoom in. Let's see if I can do this on here. If not, I'll do it the way I know. No, I cannot. Okay. Let us just move this closer. Okay, cool. From here, I'm going to look for 2 points that are definitely crossing a line. So if you're looking at the graph on in your book, then you'll be able to see that obviously we have 0, 0, correct? That's 1 point. Now we also go to 1.3 and 180. So this is 0.3, 180. From here, because we're asked to compare this speed, this change in velocity, and this one. So we're comparing this line here to this one. Why? Because they are different. We can visually see that they're different because their slopes are different, right guys? Their slopes are different. So I know that this is the turning point to a different slope. Okay, so now I gotta find a second point for this line. Over here, I'm actually at 1.4 and it stopped at 400. 1.4 and it stopped at 400. I want to make sure I get that. I did that exactly as I wanted to. That's the one I drew, so 1.4, stopping at 400. Okay, cool. Now, I'm going to concentrate only on the first one. I'm going to concentrate only on the first one that I have, nothing else. Okay, so let's concentrate on the blue portion of my line. So I'm going to zoom out. That should be good for everyone. Okay, cool. My slope will be velocity 2 minus velocity 1 over time 2 minus time 1. Again, I'm using velocity and time because the y-axis, which would have been, so if my regular equation, I'll write it over here, if my regular equation is y2 minus y1 over x2 minus x1, well here, my y's are my velocity, so v2 minus v1 over time 2 minus time 1, because this is my x section. Okay, I said earlier that this one over here is 0, 0. Okay, so v2 is 180 minus 0 over 0.3 minus 0. It is quite advantageous to write this as a decimal point, with the units I mean. So let me do that. I'm not going to erase anything. I'm just going to add in my units over 0.3 seconds minus 0 seconds. Obviously, this side, what happens to it? I never subtract by 0, so it doesn't matter. So instead, I'm going to just do the 180 divided by 0.3. So, let me pause real quick. I had to pause because I had to get my handy dandy calculator. So I'm going to do 180 divided by 0.3. I get 600. 600. Now, based off of my units, I have meters per second squared. Meters per second squared. Since this is on the denominator as well, it would be the same as seconds times seconds. Okay? So that's my first line. That is the acceleration of the first one. Now, I gotta do the second one. I'm gonna use the same exact method. I'm not changing anything. So, I'm gonna write the equation again, v2 minus v1 over t2 minus t1. This time around, I want to do the slope of the green portion. The slope of the green portion. Okay? So, my v2 is the final velocity. And again, velocity is my y number. So I'm going to do 400 minus, let me not forget the units since I'm here now, meters per second, minus, and I'm going to do this one, 180 meters per second, all over 1.4 seconds minus 0.3 seconds. From here, we use our handy dandy calculator. I do 400 minus 180. I get 220 meters per second over 1.1 seconds. So now I divide those. 220 divided by 1.1. I get 200 meters per second what? Squared. Based on these two, what can you all tell me about the acceleration? And visually, it makes sense within these two stages of the rocket launching. Take a moment. So, during that first launch, portion of the launch, the rocket is going at an accelerating super fast. It's going 600 meters per second squared. While once it reaches this stage, 0.3 seconds, it starts to slow down. It could have been that a part of the rocket came down, or it's reaching a different barrier and it's now slowing down, but it is still accelerating, so it's still traveling fast, 200 meters per second squared. That's still really fast, but it was not as fast as its initial launch. Okay? Now let us continue. How much time do I have? Okay, I'll do this in 4 minutes. So we've got this. Okay, I'm going to remove this paper. So we've worked with standard form. We learned this already. We learned standard form of our equations, standard. Which again was ax plus by equals c. From here, I can solve for my x and y intercepts. As I was saying, I can do my x and y intercepts. What I do to find the x-intercept, I would do c over a comma 0, because again, for my x-intercept, I always make my y 0, and for my y-intercept, I would do 0 comma c over b. Okay? This allows me to then solve for slope by doing my y-intercept subtracted by 0 minus my x-intercept. This gives me cb over negative c over a, which my slope here would end up being negative a over b. So notice how my slope is actually a over b, so whatever a and b are over each other, and the negative portion of that. Not only that, I can convert from standard form to my function form. Sorry guys, my arm. Standard form to my function form. My function form, again, is my f of x equals negative a over bx plus c over b, where this is beautifully my slope, and this is my y-intercept. Let's solve a problem to make it make more sense, and then we'll finish with that. Okay? So let's do our last example. I have 3x plus 2y equals 8. I want you to write it in function form. Or function notation. And I want you to use the slope and y-intercept to graph. Okay? You can do this. Do not panic. Do not panic. Okay, first and foremost, I want to move things around so I can get it as my function form, because that's what we're asked for, to write in function notation. That means I want to get y by itself. Y by itself. So I'm going to write this here. 3x plus 2y equals 8. minus 3x minus 3x. 2y equals negative 3x plus 8. Divide by 2, divide by 2, divide by 2. Y equals negative 3 over 2x plus 4. Based off of this, who is my slope? Negative 3 halves. And who is my y-intercept? 4. Okay. Now, again, we're being asked to graph this. So, I'm going to make my Cartesian plane. One, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. That's how much space I had. So 1, 2. Okay. If I'm being told my y-intercept, it means it intercepts which line? The y line. And it is a positive 4, so I literally go onto my y line and I go to positive 4. I make my dot here. That from here, from that dot, that is where I'm going to apply my slope. I have a negative 3 over 2 slope. That means I'm going to rise 3, negative 3. So 1, 2, 3. And I'm going to run 2. I'm going to choose my 2 to be positive, so 1, 2. Now, I am confident that I worked my negative signs correctly because my slope is a negative slope. I'm trying to see which visual you guys get. My slope is a negative slope. That means it matches the fact that it says negative 3 halves. Okay, everyone, you should all be ready to do your homework. Whatever questions you may have, again, if they're super hard for you, just please hold off to them for Thursday for me. But I pray that you're all able to do your homework. I believe in all of you. Bye. God bless you guys.